Hello and good evening, everyone, and welcome to the day 3 learning session of Hacker Pitch. It's a great pleasure to see such an enthusiastic and huge response from you guys. Thank you. I'm Sachi, your host, and Prem Kumar will be my co-host for today's session. So, first of all, I would like to express my sincere gratitude towards your participation in these learning sessions. So your presence and engagement in these learning sessions have already made this event a great success. So thank you so much for all. And secondly, today we are here for the learning session on Metaverse and augmented reality, for which we have a special guest, Mr. Shashwat Sahoo, who will be sharing his insights and knowledge on this topic with all of us. So I would like to add here that he is also an alumnus of IIT Madras. So it's a great pleasure to see you here, sir. Now, for all who are attending these sessions of HackerPitch, I would like to give a short intro of what HackerPitch 2.0 is. So basically, HackerPitch is a premier technical event organized as a part of Paradox. It aims to bring together innovative minds from different backgrounds to collaborate and create groundbreaking solutions to real-world problems. And by giving you this opportunity to develop and showcase your ideas, this can demonstrate the latest trends, technologies, and innovations in a particular field or industry. This hackathon can attract talented and motivated individuals from a variety of backgrounds who are interested in using technology to solve real-world problems. And often it is a key component of a larger festival or a technology event, and it can play a significant role in contributing to the overall success and impact of our Paradox. This event will obviously provide you a platform to showcase the technical skills, creativity, the problem-solving abilities, focusing on entrepreneurship and innovations. HackerPitch will encourage you all to think outside the box and push the boundaries within yourselves of whatever is possible to frame your ideas. That's all about the short intro that I was talking about. Now, I would like to hand over this session to Prem.
Yeah, thank you so much, Sachi, for giving me the opportunity. Hello, everyone. I'm excited to be your anchor for this intensive and immersive event. I understand the value of having a solid foundation to succeed in this dynamic and fast-paced industries. Over the course of the bootcamps, we will cover the topic ranging from AI platforms, gaming engines, 3D modeling, motion captures, wearables, spatial computing, and blockchain. You will have the opportunity to learn from the industry experts, network with the participants, and improve your skills through practical exercises and projects. Our team mentors will be available to guide and support you throughout the journey. I look forward to seeing you enjoy the sessions on Metaverse and augmented reality. I am excited to introduce our guest speaker for today's session, Mr. Shashwat Sahoo. He is a proud alumnus of IIT Madras, having done dual degree, both BTech and MTech from IIT Madras. Currently, he is working as a quantitative analytics specialist at Wells Fargo. In his entire career till now, he has won numerous hackathons. He has a deep understanding of the latest trends and technologies in metaverse and augmented reality, and he is passionate about sharing his knowledge with all of you. This will be a valuable opportunity to learn from one of the industry's leading experts. I encourage you to come with a willingness to learn from Mr. Shashwat Sahoo's expertise and confident that you will find each session informative, inspiring, and impactful. Please join me in welcoming Shashwat Sahoo to boot camps on the metaverse and augmented reality. Over to you, sir.
Hey, thanks, Prem. I hope I'm audible to everyone.
Yeah.
Yeah. So I want as little as possible for this to be like a lecture and as much as possible for it to be interactive. So I'm hoping that there are a lot of participants here who are actually going to build products later on. So they'll be able to come up with great ideas, and hopefully I'll also learn some of those ideas. I'll start sharing my screen probably, and then we can get started.
Yeah, sure.
So while I'm starting, anyone, if you guys would like to let me know what you guys expect from this session. What do you expect to learn in Metaverse, augmented reality, or why do you want to learn this?
Yeah, just put the response in the chat section, guys.
Yeah, I'll go back and check that.
Yeah.
Okay, so what we'll do is I'll just let you know broadly what I'm going to do today. We'll not go like extremely deep into actually building a prototype because, as you will see and as I'll explain, it's not that difficult. And if you spend a little bit of time on the internet, you'll find loads of demo projects which you can directly build. And since these are available on the internet, every one of you will be able to build them. Now, during hackathons, what sets you apart usually is how you think about a problem. It's not what you build, but how you think about solving a problem. So if you start from a problem and then you think, okay, this problem can be solved best by using augmented reality or metaverse, that's the key. If you start with augmented reality itself and then say, I want to use augmented reality in any solution possible, you will be trying to hard code a solution for a problem that probably does not even exist. So our approach today will be very product oriented, where we'll try to think about the problem first and then a solution for which might just be augmented reality, but not always. So our approach is something you could replicate for any problem, but we'll focus specifically on augmented reality and metaverse today. So we'll cover metaverse, the applications, products. We'll have a slight intro to how to build in metaverse, and then virtual reality. So why virtual reality is a separate section is because when you think of metaverse, a lot of times what comes to mind is what Zuckerberg is doing, what Facebook is doing. So what you would have seen online or on TV is something like animated figures going around talking to each other. So that's more of augmented reality or virtual reality. If there are no responses, so it's virtual reality. Now, augmented reality is one step further and is something that hasn't been explored a lot. And this is where opportunity lies for all of you to build something unique. So metaverse, as we just saw, is a place where you can, by definition, it is something where you are in a computer environment and you can interact with people, live or virtual, or with robots. But that interaction is key. Interacting in a non-real world environment is the definition of metaverse. That interaction could be anything. You could just click a button and wave to each other. You could actually be having your avatars talking to each other, or you could be playing with each other. So if you had to think of like some major example of metaverse, just forgetting what Facebook is doing, what Meta is doing, what Zuckerberg is doing, metaverse in some essence has existed for a long time. I would say like 20 years. Since we have been able to interact with computers, we have been able to interact with each other in virtual environments. So any examples, if you guys want to put in chat, I'll just have a look quickly. Any examples that come to your mind? Virtual YouTubers, virtual reality. Okay. Some more examples. Sword art game, battle games, playing PUBG. Sure. So PUBG is a great example. Yeah. So you can take an example of PUBG because you have your avatars and they're all interacting with each other, with bots if bots enter your game, or with other players in real time. So a great example that came to my mind first was Grand Theft Auto, because that's one of the first games that I remember playing online. So this is like the main metaverse that I recognize with. The current version of metaverse is something that Facebook is trying to concoct. And this is the metaverse that I think most of us are aware of or have interacted with. So how do we go ahead? How do we go to the next step? Why is like Grand Theft Auto not sufficient? That question comes because what a lot of metaverse based products are trying to do is they want to create it for specific purposes. Now, let's say I tell you I want an app that has features for complete office interactions. So I do not have to go to office. I want to work from home, or I want to go to college, but I do not want to attend lectures with my professor. I want to sit in my hostel room. Now, how do I interact as well as someone who had gone to class would? Why not just create characters in GTA, bring your prof onto GTA, and you also enter GTA, and all of you can interact on that. To some level, it is possible in it. So why not do that? So the main reason is we are trying to build custom applications that would be completely suited for your needs. So if you had GTA and you were trying to, let's say, have a class, I'm sure there would be some students who would come in with a bazooka and start blasting the chalkboard and all. So you do not want that. You want a complete environment that suits the purpose. It is, if it is a formal office setting, you want it to be as sober as possible. If it is a game, of course, you want all features that excite you. But in an office setting, you do not want that specifically. And that's why different specific purposes are necessary. So I've just put a few examples here. Now, Minecraft and Roblox are again games which are very similar to GTA. You wouldn't be able to differentiate. But if you look at the image on the right-hand side, that's something called Decentraland. It's defined here. Now, Decentraland is a new, very new application. And what happens in this is you can buy property in a real world in the sense it's a virtual world, but it exists for eternity. It's a fixed globe, and you can buy land on it. You can build buildings on it. You can plant trees, make ponds, anything in it. So there are people right now actually buying this virtual real estate, like people buy real estate, investing in it, like people invest in real estate. And even in this world, if let's say a big airport is coming up in this virtual world, the prices of all the properties around that goes up. It's exactly behaving like a real world. But now, why would people invest so much money in this? Or before that, let's take some guesses. How much do you think, let's say, the size of one house? Let's say one house goes for 1 crore in a tier 1 city in India. The area equivalent of that, the maximum, how much do you think would go for in this virtual world? In rupees or dollars, anything? Okay. Yeah, the numbers are slowly going up. It started from 0, 100, 80 lakhs was good. $100 is good, which is almost the same as 80 lakhs, 8 lakhs approximately. So yeah, around same. Yeah, obviously it depends a lot of you're saying 5 crore, 3 crore, but yes, I would go with these big numbers rather than 100, 2000, 200, 2000 rupees. That is the amount of money people are willing to spend on this. People, yes, people are actually investing real money. I'll go back to the PPT now, so we can come back to the questions. But yes, people are actually investing real money, thinking that it will pay off at some time in the future. So what is the definition of a growing economy? If you can create value out of nothing, you have just created money, you have just created wealth. Now, if that money or wealth happens to be in a virtual world, what is wrong with that? These people have just created value out of thin air and are actually contributing to the GDP of the country. So and they're not even losing land for it. You can use all your land for real agriculture, and people can just invest and build products inside this. Now, I'll give you one example of why this is important. And we'll come back to that example when I ask you questions about augmented reality later on. So let's say that I'll give you some examples. So the brands like Zara, H&M, these people are actually going and buying land on these decentraland platforms. Why they're doing that is they are going there, like in a real world, they're taking up land and they're building their virtual stores in it. The idea is when avatars are just roaming around this land, like in Minecraft even, their store will suddenly come up in front of them, a Zara store, and you can enter that. Your avatar can wear those clothes. get a sample, and you can wear the same clothes in real world. Now, if you think logically, there would in fact be people who want to spend some money to wear the same clothes in real world as their avatar wears in Decentraland. And this is what big companies are betting on right now. So what you see here is a big platform which is enabling a lot of small startups or small companies. This is very similar to what Apple or Android, Google did. They built a phone, they built an app store with a few apps on it. Those apps were good enough to keep you engaged. They had a great calculator, a great camera, a great FM radio, a great music player, but there were not enough apps after that. What they did is they opened it up to everyone. Then there were games built, Talking Tomcat came, Facebook, Instagram, all these apps were built for Play Store and App Store. And when that happened, that hooked people to those apps, but in turn also hooked people to the phone that was built by Google or Apple. That is exactly what is happening here. Decentraland was one of the first movers in this, and they are going to make huge money if someone else is going to build. But whoever builds, they as well can be big. Today, Google is big, Apple is big with their phone. But Facebook with Instagram and Facebook app is also way too big inside this environment. And that is something that you or I could also build in this platform. So that just remember the example of the fashion apparel that I gave, like Zara and all. We'll come back to that when I ask you questions on augmented reality and why that is important. Yeah, so this is one of these examples. So inside this virtual world, let's say this is your avatar. You can see clothes here. You can customize clothes. You can make designs. You can have a virtual economy completely functioning inside this environment. And whatever merchandise you build inside, there could be a real world supply chain that supplies you those clothes. So you're actually generating job revenue outside as well as inside. And you do not have to set up a physical store. This is the next best step after shopping on Myntra or something. Yeah. So we've covered what Metaverse means, what Metaverse is capable of doing. We'll just broadly cover what technology it entails. So it could be augmented reality, virtual reality, both of these. We did segregate these two, but I'll just reiterate what the difference is. So virtual reality would be your avatar playing inside this game. So when I even mentioned Decentraland, Minecraft, PUBG, or GTA, all of these are metaverse with virtual reality, because you exist in a reality that is completely virtual. You do not live in your own world. Augmented reality, by definition, means that you're augmenting or adding on your fake reality onto your actual reality. So if you wear glasses and something is projected and you see the world as something it should not be, that is augmented reality. Now, what happens with Metaverse is, since it is a new technology, people are trying to club all the new hot keywords into it and make a new world out of it. That's why you can see blockchain, artificial intelligence, anything that is a buzzword today is being clubbed together to sell it as a single package called Metaverse. I do not completely agree with that philosophy, because Metaverse is more about probably interacting, and that virtual reality and augmented reality alone are doing. Blockchain and artificial intelligence are kind of different things, so I wouldn't go too deep into it. But if you actually read more about this environment and development in it, people are using blockchain, artificial intelligence. Augmented reality is something that is new, because, like I gave you all the examples here, all of them were based on virtual reality. There are very few big examples of augmented reality that come to mind when you directly start thinking about it. So this gives us the potential to move on to augmented reality and think of ideas. Yeah, this is the first example. Now, why I put two images here is, look at the first image. How is that augmented reality? I'll go to the chats now and I'll expect some answer on why that is Is my screen not visible? Bhagyesh is writing that.
Yeah, it's visible, sir.
Yeah, great. So, yeah, I'm anyway out of my presentation right now. Give me the most rudimentary or the most basic example of virtual augmented reality that you can come up with. So there's a great example here. There are in fact two examples, but you'll see this one on the right is Pokemon Go. Pokemon Go is probably the most famous example of augmented reality. Why it is augmented, again, I'll just explain it so that you guys can come up with more examples. Augmented reality because you have a real world, you have roads, jungles, everything in your real world. But when you bring your camera, phone camera in front of it, it augments a Pokemon onto it. So if you live by the beach and you take your phone there, you'll actually see a Pokemon splashing around in the water. That is augmenting a Pokemon onto your real world. Now, this happens to be a very advanced, relatively very advanced application of augmented reality. I want a very basic example, the most basic example you can think of. And this is a hint, this image, or the answer basically. But before I come to it, I would like to hear from you guys. Snapchat camera filters, again, they are great examples, but they use a smartphone, they use a camera, and they use artificial intelligence. These are highly complex problems that have been solved over 20, 30 years, and they are very advanced devices. Someone wrote scope, Abhishek. Can you explain that more? Instagram filters, again, great example, but those are, again, using complicated systems. So Abhishek is writing scope on guns. So that's kind of what I exactly meant. Yeah, bioscope, any of these. So if you even think of a periscope in a submarine, all of these have existed for more than 100 years. You put on a zooming binocular, even that is augmented reality. Why? Because a real person exists in a real world, and you could have seen him or her with this glass, but you're putting a crosshair on this. And when you put a cross, you can see a dot, and you're augmenting the reality and focusing on only one dot. And this is helping you improve your aim. So you are augmenting an image for a specific purpose, and that makes this augmented reality. With no technology, no electricity, no smartphone, this is the most basic example of augmented reality. So I just gave this example so that you guys can understand augmented reality from the base up. And now that we have understood this, we'll move on to different types of ARs. So I would expect examples for all of these. One or two examples have been given. Let's start with the first one. There are three types. Marker-based is something where you just put one point and that becomes a trigger point. So you would have seen this in a lot of museums. There are QR codes or there are simple logos built, and you can just take out your phone, and when you scan that, that becomes a 3D image. This has helped a lot of museums save prices, save cost on building actual models or replicas of models that exist somewhere else in the world, which they cannot afford to bring here. So this is a great learning tool for students. This is marker based. Then there is markerless. Markerless is your Pokemon Go type of example. So Pokemon Go did not have any marker on the road which told it that here is the Pokemon where it should come up. It was its inbuilt engine which told that just place a Pokemon here. So that is marker based and markerless. We'll come to projection based later, but let's go to some examples. You can just type marker or markerless and then give your example in the chat. Any examples of augmented reality applications, marker or markerless? So I gave of one example each. Yeah. Markerless is the maps where we have symbols to turn. Yes, that is correct. So this would be actual roadmaps, not the just direction map you use, but Google views, street views kind of thing. In that, if you see the markings appear, that is markerless because there is no mark on the road. The app is telling you turn here, turn there. Yeah, so Praveen was right on that. Markerless is filter. Yes, that too is right. Amazon uses this technology nowadays with Google Lens. It shows a 3D image of furniture in your room for you to decide what it looks like. This is markerless. We'll come to this later. Maria, I would like you to come back with this point at that time, but this could be marker or markerless. You can think about why, but we'll come back to that. Tiger in Google AR. Yeah, this again this. So let's stop marker sky portal to view stars. Yes, that's a great point. We'll stop here, let's say, and again 3D lens card, 3D frames. There are a few points that can make a lot of these examples marker or markerless. Let's pick the example of lenses. In so when you take your lenses, you can say that it is markerless because software is telling it to place the glasses on your face in the right measure. That is markerless and it is logical. But do you think, I'll just leave the question out in the air and we'll move on, but do you think that if there were points, let's say you were to just put one dot here, and the app could use those as reference points for the size of your face, would not that make your augmented reality more accurate? Here, the software is trying to predict what's the size of your face and approximately fit it on it. But if you were to make it a marker-based augmented reality, just put two dots here or wear a frame and then you can superimpose on it. Would not that make it more accurate? Just think about it. Yeah, like in animations, great example. So in animations also, even in CGI, you could completely animate it, completely put CGI, but even still, there are dots made so that it makes it easier to make the dimensions, cuts, angles more accurate. So it's a trade-off between how much effort the software wants to make versus how accurate it wants to be. So Lenskart being more generic and more easy to use, it does not want to use markers. A won't marker is used in every AR to track point of projection or simulation. Not really. So if you had the example of tigers in Google Lens, like they said in the example above, Google's tiger, let's say, I'm not sure if you're referring to some other tiger, but I'm just assuming there are these animals that you can superimpose in your own bedroom or in your own house. When you do that, it does scan for surfaces. But once you have done that, you can increase or decrease the size of the tiger and place it anywhere you want. That is not marker behavior. And that is why there is some inaccuracy in it as well. It wouldn't be able to separate between, say, your table and your floor. In Lenskart isn't face the marker. So it takes dimensions of your face, but it is heavily reliant on the artificial intelligence that measures your face. So this is more of measuring your face than using pre-built markers. If it were a marker, like I said, you would actually, like, the most crude method for markers here would be you drawing two lines on your face and it just taking those two lines. It makes it very easy for the software, but it makes it difficult for the user. Eyes are the marker, but again, measuring eyes is quite difficult. So I'll go back to probably this example here. Let's say, like here in Pokemon Go, you could say that the streets are the marker. If it sees a street, it will put some Pokemon that is specific to that. But that is not what happens. What happens is, on the back end, Pokemon Go has this map where they keep track of in which area, how many Pokemons of which type they want to populate. Similar with Lenskart. They know, they have trained it on a lot of data points of eyes, and because eyes are of different shapes, sizes, not all eyes are uniform also. So both your eyes wouldn't match. If you were to directly take, let's say, one sunglass, and say your face has been measured, your eyes have been measured as 38 millimeters, we'll just put one glass on that. If you were to do that, it wouldn't make the best fitting glass. But instead, if you just put two lines here, and let's say one line here on your nose for the holder of the lens, that would make it very accurate, because reading lines is much more easier than reading contours on your face. How your face is going up and down, that's more difficult to read with computer vision. So that's primarily the difference. It's more of a trade-off between what you want versus how much quality of it do you want for marker and markerless. Final one is projection based. Now, projection based is here, this keyboard. Now, I personally think this is a little overdone, but let's say you, instead of using a normal keyboard or carrying it around, you wanted to use a projector that projects a keyboard onto the table. Now, this is extremely portable, and when you press these buttons, the projector would also read where you are placing your finger, and based on those interactions, feed that data as input. So this is projection based, where you can project onto real world and you can interact with whatever is available in the real world. In my opinion, this is the most interactive or the truest form of augmented reality, but there are only certain cases where it is actually practical to do this. This example of a keyboard wouldn't be too practical, but from portability perspective, definitely a good idea. Any ideas or examples that you can think of in this?
Mobile phones or TVs?
Can you elaborate further? Mobile phones, TVs?
सर आते हैं अभी फोन में सर तो ट्रेनों का नहीं देगा तुमको अरे दो आदमी था वो देवो करता होगा अब कौन सा दिखा चाहे 369
Abhishek, will you please mute yourself?
तो वही बात लेते हैं बोर्ड के साथ कौन सा है आपके
Yeah. Can I speak?
Yeah. Vedant, you were saying something?
What was I thinking? Like, see how these keyboard projectors are basically projecting things on a surface. So, like, there can be two sticks, like horizontally for TVs, or projecting on a wall, or something like smartphones, which you can tie up to your wrist, and it will project on your palm. Like,
yeah, I like your second idea better. So in the first idea where you're talking about TV, what would be the interactive component? You're just projecting onto a screen, much like a normal movie hall projector, but can you really interact with that?
not that really, since TV is mostly for like visual purpose. Then,
Yeah, right.
but smartphone thing on a
Yes.
watch
Yeah,
will be a great thing on your
definitely.
palm.
Yeah. So people always want to reduce the amount of weight they carry on while increasing the number of features they carry. So definitely you can't play the games in your highest resolution on a augmented reality phone that you're projecting onto your palm. But if you had to say take notes, if you had to do some calculator based purpose, and you had a smartwatch that was just projecting out onto your palm, that would be the best technology out there,
Yeah.
right? Yeah. Bhagyesh is saying, so there's a technology that which detect the terrain. There is a lot of sand and it detects the depths and heights and gives the terrain lines as in geography. Yes, there is. I'm not sure if you're talking about some other point in connection to this, but you're right if you just wanted to point that out.
Also, one more thing I want to add here.
Yeah.
There can be like smart glasses, like virtual reality glasses, which will directly project the screen or images onto your glass screens than wearing big wearables. Like, we can
Yes.
reduce the size using this technology.
Yes, that's very true. that would be kind of like markerless technology, not projection based, but that is probably the most prevalent technology in augmented reality that exists today. A lot of companies are trying to come up with these glasses. Even like Google Lens is there. A lot of these people have glasses which can project something onto your screen, and that is augmented into the real world. So you could, I mean, you would have seen, say, Black Mirror or some other TV show where they show all this, where you can just scan the person in front of you and bring up their Facebook page or their Insta page. So, and that would be visible on your glasses without anyone knowing. So that's like, uh, that's not really that much of sci-fi anymore. It is kind of reality today. We can afford it. We can do it. The issue in this is primarily of making the glasses as comfortable and as light as possible with enough battery life. So it is more of a hardware problem than a software problem. But yeah, there are. We'll come to AR's different technologies. Yeah. So this is it. The technologies. There are software development kits. There are development environments. I don't want to go a lot into it because there are so software development like basic libraries, APIs are very easily available, which you can directly plug in and start using it by reading its documentation. Development environments and 3D modeling lets you create these worlds that I was talking about. Uh, Everyone, Apple, Google, they all have built their platforms where you can go and build these, very much like App Store and Play Store. But the most popular one that exists out there is Unity. So I'm sure a lot of you would have heard of Unity, but for those of you who haven't, Unity is basically a game studio which is a gaming engine that lets a lot of developers build great games. There have been a lot of very, very popular games on smartphone as well as on your computer that have been built completely on this engine. Now, because they were so good at 3D modeling and world building, they have leveraged that to create an open source kind of platform where people can go and build their own worlds. And if you want a starting point, this is what I would recommend. You can start there, and you can start, it's quite easy also. You can start building small worlds. Of course, the software coding is not as easy. There is a slight entry barrier, but if you were to use 3D modeling, this is the best engine for you out there. This is related to software. The main problem, like we were talking about, comes with hardware. What hardware do you want to choose? If you're going to use something like glasses, it there isn't much in your hands that you can do as a software developer because the glasses would not have that high adoption. But if you go for something like smartphones or the watch that we're discussing, almost everyone has smartphones with cameras, with good quality cameras and decent RAM that can run your augmented reality softwares on the platform. This means that if you are going to build something, best build it like Pokemon Go. Build a simple app that can. So the most simple example, even Apple and all have done this. But if you were to try to do this, just go build an augmented reality map app that takes a scale and keeps it on real world objects and just measures them, measures the length of any object that exists in your room. So if you have a table, it can tell you it is say 3 feet by 2 feet or 5 feet by 1 feet, whatever. So if it can do that, that is the most simplest example of augmented reality. You would be tracing the contours, the distances, and once you can do that, you can augment anything onto the real world. That is kind of the first step. Other services, this is just for building products with multiple teams. You can use Slack, Zoom, communications. I do not want to cover that right now. Yeah. So we'll come to the applications of AR. We'll go to a lot of them. I'm just covering the broad topics, but we want to come up with exact applications after this. Education, like I mentioned, the museum example, what this does is works as an enabling tool for reaching to places where there isn't much accessibility. Let's say you wanted to show the skeletal structure of a human or a dinosaur, let's say. And sure, that is available in a university. Sure, that is available in probably a lot of schools. But if you go to a very distant school, which is not having great access for these things, and you want to explain the intricacies of the human skeletal system, let's say you wanted to explain each bone on the backbone of a human and tell what differentiates it, which is what is the importance of each of them. How would you do it? If you paste an image on a book, that book will have a black and white copy with very bad resolution. And is that something really that would interest a student? Not really. Here, with one smartphone, you could augment it, or one screen, you could augment it on the real world, and a group of students around it could actually interact by rotating it and seeing a 3D rotating figure in front of them and understanding the size, girth, and height of each bone. Same for healthcare. It's very closely related. That's why I gave that example. When you go to healthcare, I won't go into proper surgeries or operations, but even for viewing an X-ray, like you would have seen people, doctors put X-rays under light and see which bone where has a crack. A very similar example for that would be, let's say you have a very remote connection with a doctor. You are connecting with them virtually, and you want to show your leg which has been swollen for a week. Now, if you can generate a 3D image of it, scan it, and the doctor can view it in their lab, they will be much better able to judge what the issue is. Now, this 3D scanning of turning the whole leg around can be extrapolated to retail. If you are rotating your leg and seeing what the issue with the swollen leg is, you can do the same for a great pair of boots that you wear on your shoes. You don't really want to go to the store, try on each boot. What you can do is simply take your feet and put your smartphone camera on the feet and say, I want to wear these boots. It will augment it onto it and make a complete image, and you can judge if you like it or not. Similar examples exist in manufacturing and entertainment. Of course, Pokemon Go, I think, is the universal example everyone gives everywhere for this, which brings us to the fact that all these industries can have applications in augmented reality. So now we have given basic ideas. I want you guys to come up with some great product ideas. I'll show 2 ideas and I want you guys to come up with more. So this is the shoe idea I was talking about. Instead of just viewing the shoes in 3D, rotating them, you can actually bring your camera onto your feet and wear these and check these out. It's augmenting it onto it, and this is most probably the next step to e-commerce. I, for a fact, know that a lot of e-commerce apps are trying 3D images, if not for apparel, for furniture. So that is our second example here. A lot of you guys also gave this example in the chat when we were interacting. If you want to see how your furniture looks in your house, you could bring it, place it, not like it, return it, and then get something else. It's a 2-3 week process. Instead here, if you just scan your camera around and you say, I want to place it here in this size, this much further, this much back, it would do the exact thing. You can rotate the entire thing and make a video out of it. You would have an actual live video of how this chair looks in your house along with all the other aesthetics that you have chosen. Now, why these are important for furniture companies, Pepperfry, Furlenco, these people, is that it ensures that people are happy with what they have purchased. And more often than not, the cost of returning a product and getting another one falls on these startups and companies that are selling furniture. So this is not just a great user experience, but it actually saves cost for the companies involved as well by making the decision-making process simpler for the customer. Now let's go to you guys and examples. If you are to build a product for the hackathon, don't give out your great ideas to me right now, probably, but we can have some ideas. SOP for assembly of components. Would you want to elaborate on that? I can also see, is there a 3D image for paint color selection? I am not sure what that question means, but if you're talking about like an app where you can like click and select paint, and then that would be completely visible on your actual walls, I'm sure some similar product would exist, but that's a great idea. An app can be made where we click the photograph to select paints on walls. Yes, yeah, definitely. So one issue that I can think of with that right now is there are a lot of paints. When I say green, I would be completely missing out on 100 different types of green, and that actually exists in the paint industry. When it comes to wall painting, what hue, what color of green do you want? Now, when these companies give out small samples of paints, you can actually see the color with your bare eyes, and that will make you believe. What happens with smartphones is a lot of the times the resolution and the color quality, the color gradient, the color saturation is not in your hands. If you take a phone that tends to highlight green or blue color by a lot, that's how your color would appear. And then you would be thinking, oh, this seems so bright on my phone in augmented reality, but now this seems very dull. How do you solve for that? House design planning. Yes, this is like very similar to the furniture one that you're talking about. This is a great idea. Maybe what we can do is have a completely empty room, have certain preset notions of one table, one chair, one sofa, and place the camera in one corner, and the complete room will be set up via software. And then the user has the option to move around the furniture in the phone, and it will accordingly get adjusted in the augmented reality. In architecture, Abhishek is asking, what are your experiences in the field of augmented reality, virtual reality? So I was in the robotics club at Center for Innovation in CFI, if you are aware of that. And so basically the robotics club of IIT Madras. So as part of that, we worked on a lot of augmented reality. I personally have more experience with augmented reality than virtual reality, but I have worked with a lot of people who have used virtual reality. So how, I'll give you an example of robotics, let's say. So what we do is we trial room in stores for quick try on clothes. Yes, that's a very true example. So I'll just explain the robotics thing. So let's say you have a robot and you want to see how it behaves in a particular environment. So there is something called ROS, Robotic Operating System, that lets you simulate these environments and then animate your robot to move in that environment. You can introduce gravity, you can introduce gravity as 2G also, and then corners, spaces, everything, and ensure to check how your robot will move with all its actuators and its motor, its power, everything. This is basically virtual reality. The next step after this, what we do is we bring computer vision. A robot should be able to navigate its environment, and that is where augmented reality comes into play. This computer vision is the first step of augmented reality, where you gauge how far a robot is from some place. You use cameras to see the contours and what the gradient is, what the depth is, how far away a wall is, and how far your robot is from hitting that. So yeah, first step is virtual reality, then augmented reality, and then your actual robot is working. Yeah, I just have one more example, makeup. So I think someone came up with this, but what do you guys think would be an application of augmented reality in makeup?
Like filters, like Instagram filters.
Sure. So I'm talking about actual makeup. So let's say if I wanted to do makeup, in person, how would augmented reality help me? Any ideas on that? I'm not talking about purchasing makeup or using filters instead of makeups, but actual makeup. If I wanted to do makeup on my face right now, how can augmented reality help me do it better? Now, I will admit it to you, I know nothing about makeup. So if I were to do makeup, I'll probably do it pretty badly. I'll put dark spots somewhere, white spots somewhere, lipstick somewhere, and
So
that is not good. Yeah, go ahead,
the
Vedant.
thing with makeups or anything related to that, like watching shoes on your feet, it's all or clothes into the camera. It's all about feel, like what you feel on actual human, uh, not like on screen, because you cannot directly judge. No,
You're talking about makeup or you're talking about clothes?
in general, I'm talking about things which are related to direct human touch feel.
Yeah, yeah. Sure. So definitely for material clothes, definitely material is a big selecting point, and that is something that cannot be replaced. But you have to segment your customers. So you wouldn't target customers who are looking to completely understand the material of the cloth. But there are a lot of customers who go on Mintra, see the brand, and say, okay, this must be good quality cloth. I just want to see how good it looks. One, and two, how good it looks on me. So Mintra will completely solve the question of how good it looks. But how good does it look on you specifically can only be solved by trying it on in person or to some extent, note that, with augmented reality. Now you have to see if this some extent is enough to make your customer pay for it. So if they are willing to do that, this is definitely a solution for you. If not, we do not have to force a solution into anything. So augmented reality is not and cannot be a solution to all your problems. I'll just go to the comment section because a lot of people were giving answers. Maybe it can get your color tone and dark spots as you told, and it can enhance where to do what. Yeah, this is very close. Help you select perfect look by hand, helping you selecting what suits you best. Yeah, you can see your looks after removing spots and use various cosmetics. Yeah, so I'll go back to the PPT now. You guys are all very close. I mean, you guys are correct, in fact. So this is one example, and I do not know much about makeup, but I know two things. There are concealers and there are highlighters. So concealer basically hides some features, highlighters accentuate some features, and together you can create contours and sharpness and curves on your face that make it look prettier. So this would give you the exact points where you should, let's say, use these dark arrows as concealers, these light arrows as highlighters. And if you follow these by looking in the camera instead of looking in your mirror and use it at exactly those points, you would be able to do a better makeup job than you would have been able to do on your own without any tutorial or guide. So that was my last example. Uh, I think that the main goal that was there for me was to make you guys think in different angles where you can use it as wildly as possible. Because if you're going to actually build something in a hackathon, your ideas have to solve problems that if someone hears it, they instantly think, yes, this is something that is a unique application. And this is truly where augmented reality is needed. Nothing else can solve it as good as augmented reality. If there is something better, just leave augmented reality out of it. It does not have to be this answer to everything. And with that, I would like to close this presentation and we'll completely go back to questions now. Yeah. Any questions, anyone? Haircut. Yes. Do you want to go ahead elaborate on that? Mutum Lakshman Singh. Okay. While Mutum is joining, anyone, any questions? AR and mixed reality same? Kind of. So mixed reality is basically you mixing augmented reality, virtual reality, everything together. So metaverse is the true meaning of mixed reality. Let's say you were to join with augmented reality and view everyone in augmented world in front of you, but some of your friends don't have that capability, so they have just sent their avatar in virtual reality. Since there are interactions going on with virtual and augmented reality mixed, it is all called mixed reality kind of, and your real world is also a reality that is mixed in it. In what way does augmented reality help disabled people? Mm, it would definitely depend on what kind of disability you're talking about, but there are definitely solutions. Uh, a great example, which a friend of mine was working on, I'll just give that example. This is more of virtual reality, not augmented reality, but they had built a solution for PTSD. So what they did was you just wear your virtual reality glasses, and this used to train people through situations through which they had to work out in a virtual world. Since they know it is virtual, the stakes would be lower. But because it is so interactive, they would be forced to face some of their fears. And in a phased, slow manner, you can train people to overcome some of these fears. So that is a great example of helping out people with PTSD and mental health with virtual reality. Uh, then is augmented reality a type of AI which is visual? It's not a type of AI, but more of software that uses AI to some extent. So if you want to augment something onto a table, you have to have software, computer vision, which should be able to measure your table and where it is placed. And computer vision at the core is artificial intelligence. Roadmap for becoming AR developer. So that's kind of what I was covering in the slides. I saw some point. Yes, you can have the slides later on, but basically it means you have to have software development kits, APIs, libraries exist. A lot of developers have built third-party APIs that you can just import and start using in your environment. Your building environment and 3D modeling softwares, they can be the platform for Google or Apple, which I'm sure will help you integrate it very easily and to apps onto the App Store or Play Store. You can use stuff like Blender for 3D modeling of individual objects and then import them into your own world if you're building something that does not already exist. And the main idea is work in an environment that is very accessible to people, I would say. So something like Oculus by Facebook Meta is the most popular kind of virtual reality item out there. And smartphones, you can use Apple or Android, anything. Just build something for the smartphone that people can use. Pokemon Go was popular because it was a very simple application for the users, not for the developers, for the users, very simple to use on any simple smartphone with a camera. So think of that. We're at 7 o'clock. Prem, if there are no questions, yeah, one question from Abhishek. Decentralized via land, how could the price will be estimated? And if there is too much land to buy, don't you think there will be problem of supply and demand? Definitely, there is a problem of supply and demand, and that is exactly what is driving the prices. So this is like real world betting on what the price will be, and then people are going in and saying, I want to buy this land for $100. But if someone else says, no, I'm willing to pay $200 for this, the price just goes up, like in the real world, very much like in the real world. Yes, Lenskart does that. Yes.
Yeah, should we wrap up, sir?
Yeah, sure.
Yeah, thank you so much, sir, for such a wonderful session. See you on the campus in May.
Sure, sure.
Hope you
Happy
will
to
be
interact with you, all of you.
Yeah, thank you so much, sir. Thank you all for being present in the end of this session. We hope that you focus on this session as informative and valuable. We believe that the knowledge and insight you have gained from this session will be instrumental in the Hackathon's main event. Once again, thank you for attending this session. Thank you, everyone. Thank you, sir.
Thank you. Bye, everyone.
It was such an amazing session. Thank you so much, sir.
Bye.
Bye.
Thank you all.